Plastic, the most widely used material on our Earth, but is also the most polluting. Plastic has had a variety of detrimental effects on our ecosystem. Not only does burning plastic garbage have a negative impact on human health, but the amount of plastic that gets dumped into the ocean on a daily basis has hurt numerous life forms. However, after much research carried on by scientists, they have now discovered a better and safer solution creating plastic, so that plastic will no longer play a part in polluting our Earth. Hi, my name is Chris, and I'm currently a chem student from Miss Mariana's class in Springfield School. And today, I will be talking about degradable polymers. In this video, I will be covering two different types of degradable polymers, which are biodegradable plastics and photodegradable plastics. But before I begin, what is a degradable polymer? As you all know, normal plastics that we see in our daily life cannot decompose safely when thrown away as a result of their non-biodegradability caused by their lack of reactivity. So, chemists are now developing degradable plastics that break down when they are discarded. Now I will begin explaining further the two different types of degradable polymers, which are biodegradable and photodegradable plastics. Biodegradable plastics. Some plastics, when buried for many years, eventually become brittle and break down into smaller pieces that can be decomposed naturally by microorganisms in soil. If the surface area of the plastic being buried could be increased, then it could degrade much more quickly. Scientists have developed plastics that contain small amounts of starch granules that the bacteria and fungi in moist soil can break down. So the plastic is broken into smaller pieces with a larger surface area for decomposition to occur faster. The image above shows a plastic fork being degraded over time by microorganisms in soil. Cool, am I right? To make it easier for the microorganisms to digest the plastic, many scientists are now making plastics that are now made from monomers derived directly from plant materials, such as PLA. And for those of you who do not know what PLA is, PLA, also known as polylactic acid, is a polyester made through fermentation under controlled conditions of a carbohydrate source like cornstarch or sugarcane. Its building blocks can either be lactic acid or lactide monomers. They will later be polymerized into PLA. Initially, the corn goes through wet milling. Here's where the starch gets separated. The starch is then mixed with acid or enzymes and heated. This process breaks starch into corn sugar. Finally, fermentation of glucose produces lactic acid, which will be the basic constituent of PLA. Two methods for manufacturing PLA plastics from lactic acids are applied. The first one uses lactide as an intermediate state, which results in greater molecular weight. The second method consists in the direct polymerization of lactic acid. Now, back to the subject. In polyamides such as nylon, the amide links CONH can be broken down by hydrolysis in acidic conditions found in landfill waste dumps with rotting vegetation. In polyesters, the ester links are similarly broken down by acid hydrolysis, forming alcohols and carboxylic acids. This susceptibility to hydrolysis makes both polyamides and polyesters biodegradable, unlike polyalkenes, which are non-biodegradable. I will now explain further the process of hydrolysis to break down the amide links in polyamides. Firstly, the link is broken by hydrolysis with an acid or an alkali. The amide is refluxed with, for example, hydrochloric acid or sodium hydroxide solution to hydrolyze it. However, in this case, we will be focusing towards the acid reaction. The products of hydrolysis of a substituted amide with acid are a carboxylic acid and a primary amide. The amine formed will react with excess acid in the reaction vessel to make its ammonium salt. For example, R2NH3 plus Cl- with excess hydrochloric acid. Now, in polyesters, esters can be hydrolyzed by heating under reflux with either an acid or a base. Same as the case before, we are only focusing on acid reaction. So, refluxing it with an acid simply reverses the preparation of the ester from an alcohol and a carboxylic acid. The acid catalyzes the reaction. The reaction is reversible and an equilibrium mixture is established. In acid hydrolysis, there are always both reactants, ester plus water, and products, carboxylic acid plus alcohol, present after the reaction. Moving on to the other form of degradable polymer, photodegradable plastics. In short, photodegradable plastics basically means plastic that will get degraded by the sun over time. That's basically what it means. Now, for the longer version. Monomers of photodegradable plastics consist of a carbonyl group, a functional group consisting of a carbon-oxygen double bond. These carbonyl groups absorb energy from the ultraviolet region of the electromagnetic spectrum. This causes the bonds in the region of the carbonyl group to weaken and break down. As the polymer breaks into smaller fragments, the plastic will biodegrade much more quickly if it is not chemically inert. There is some debate as to whether photodegradable plastics are better for the environment or not. In a landfill site, for example, these plastic waste is often buried under other rubbish and eventually soil, so there's no light available to trigger the breakdown of the polymer chains. They also make recycling plastics problematic as they could weaken a recycled mixture of different plastics when it is put to a new use. That concludes this short video about degradable polymers. I hope you all learned something new about these fascinating types of plastics. Thank you for watching, and until next time.